This video is not to discuss about laws of motion or things related to it. This video is not to discuss about laws of motion or things related to it. But in here, we are going to discuss the topic that you see written, which is differentiation or derivative. Now, differentiation or derivative is a part of a branch of mathematics called calculus. In calculus, we are going to study about, of course, derivatives. You're going to study about integration, differential equations, continuity, and other things. You'll learn about these topics in mathematics in a greater detail, but mostly in class 12. So in this video, I just want to help you understand and learn some basics about differentiation or derivative. Now, the reason we are studying about these mathematical topics is because we need differentiation and also integration a lot in physics. We need these mathematical tools to help us understand many concepts in physics. So let us get started with the topic here. As you can see, it's written differentiation or derivative of a function. So let us understand what this function is first. So if you say y is a function of x, which is written this way, and you read it as y is a function of x, what you mean to say is, you mean to say that y is dependent on x. Like we have y is equal to x plus 3 over here. So this equation is showing us that y is dependent on x in a linear manner. Likewise, y is 2x squared plus 3x plus 5. Also this equation where instead of y I have simply written f of x. So f of x is 6x cubed plus 2x plus 1. So all of these equations are showing us how y is related to x or how y is dependent on x. Also get one thing clearly, that if you plot the graph of the different equations that you write, you will see that each of the equation is going to give you a definite curve. So all equations that we have where x is related to y in some manner, so every equation is the equation for a certain curve. Like for example, this equation is the equation of a famous curve which is a straight line. This equation is the equation for a parabola. This equation where x is raised to the power 3 is the equation for some kind of a complex curve. The higher the power of x, the more complex the curve will be. So remember, y is a function of x simply means that y is dependent on x. Now, it could be many different ways in which y could be dependent on x. Now, before we actually start discussing derivatives or differentiation, let us give a look at the graph here, where I've plotted the dependent quantity along the y-axis, of course, and the independent quantity along the x-axis. And we have two straight lines shown in the graph, straight line A and B. Now, if I ask you which of the two lines shown here is steeper or more inclined, just by looking at the picture, you can tell that line B, straight line B, is more inclined or more steep than line A. But if you're actually asked to prove which one is steeper, what you will have to do is you will have to find the slope of these two lines. I believe you all very well know how to find the slope. What we do is we take or we choose any two random points lying on the line and we find the change in x and the change in y. This horizontal line is going to give us a change in x represented by delta x, and this vertical line is going to give us the change in y or change in f of x given by delta y. And when we divide delta y by delta x, what we get is the slope of the line. If we find delta y by delta x for this line B, we will see that this value for straight line B will be more than that for straight line A. Also, slope gives us the rate of change of y with respect to x. That is, what is the change in y as the value of x changes. So slope also gives us that. Now, if the change in x is very small, that is, if delta x tends to 0, then delta y will also be very small. That is, the change in y will be very small if the change in x is small. Therefore, for delta x tending to 0, the small change in y is represented by a dy, and the small change in x is represented by a dx. So to say, for small changes in the values of x and y, the slope is given by dy upon dx. which is also written as d dx of y. Therefore, the value of the slope for small changes in the values of x and y is what is called the derivative or the differentiation. But derivative is basically written in this form and it is read as d dx of y. So d dx is like the operator here, which is operating on the function y. You can see here y is some function of x. Like y is a straight line here, y is a parabola here, y is some complex curve here. So y will be some curve, and when you find d dx of it, or when you find the derivative of that curve, you are trying to find the slope of that curve or the rate of change of y with respect to x. Now this is only a very basic idea I'm giving you about derivative, and like I've already mentioned, you will learn about derivative in a greater detail when you study about it in your mathematics. Now I've listed some very basic formulae here with regard to derivative, of course. It would be good for you if you can remember these different formulae. d dx of x is 1, d dx of x to the power n is equal to n x to the power n minus 1. Formula number 1 actually comes from this second formula. This is important. Differentiation of a constant or d dx of a constant is equal to 0. d dx of sine x is cos x, d dx of cos x is minus sine x. One last thing I want to tell you, that is, if we are plotting displacement denoted by a y along the y-axis and we are plotting time along the x-axis, then this straight line is giving us the motion of a body. So the slope of this straight line, or for that matter, the velocity of the displacement, because displacement here is a function of time. So d dt of y will give us the slope or the velocity of the body here.